Light and reflection. What is light? Visible light is a form of energy, also known as electromagnetic radiation, that is visible to the human eye. Some common sources of light include the sun, light bulbs, and candles. Light travels as waves. We represent the direction of motion of light by constructing perpendicular lines to the wavefronts and calling them light rays. So if these are the wavefronts, then the light rays travel perpendicularly through them. This is called a plane wave front. So the waves are parallel to each other like this, and the light rays are, once again, perpendicular. You can see a pencil on a desk from any angle, as long as there is light in the room and nothing in your way. Light rays from the overhead light reflect off of the pencil in all directions, as shown. You can see the pencil because some of these light rays end up entering your eyeball. If you are in a pitch black room, you can't see anything because no light rays are bouncing off of objects and ending up at your eye. The bouncing of light off surfaces is called reflection of light. The incoming ray that hits the surface is called the incident ray. The ray that bounces off the surface is called the reflected ray. To help in the understanding of the behavior of light, an imaginary dotted line is drawn at 90 degrees to the surface where the light strikes the surface. This imaginary line is called the normal. All angles are measured against the normal. The law of reflection states that the angle of incidence is equal to the angle of reflection. When you look into a plane or flat mirror, you see an image of an object which appears to be inside of the mirror. This is called a virtual image, since the light rays that are reflected into your eye are not actually coming from the image. The light rays look like they're coming from inside the mirror. Human eyes did not evolve to understand mirrors. When you see an image in a mirror, your brain thinks that that is where the object really is. Your brain assumes that the light rays reaching your eye must have originated inside the mirror. The human brain assumes all light travels in straight, uninterrupted paths. When you look into a mirror, you see an image which appears to be behind the mirror, also called the dark side of the mirror. The distance from the object, located on the light side of the mirror, to the mirror, so this distance here, SO, is the same as the distance from the mirror to the image, SI. A virtual image is formed by extending the light rays to a place where they converge on the dark side of the mirror. This image cannot be projected or focused on a screen. An observer can only see the image of an object in the mirror if the light ray from the object strikes the mirror at an incident angle theta I that will reflect it at a reflected angle theta R, where theta R equals theta I, and it goes straight to the observer's eye. A line connecting the image to the observer passes through the mirror. These lines, in gray, represent the backside of the mirror, or the dark side. An observer at point A can see the reflection of the jug in the mirror. However, the observer at point B will not see the jug's reflection. There is no image that can be connected to observer B that passes through the mirror. The mirror is not long enough. There's no possible reflected light that can reach observer B's eyes. In your classroom, you can place an object in front of a plane mirror, like as shown in the image. Then students can go to places in the room where they can see the reflection of the object, and other places where they cannot see the reflection of the object. Mark out these locations, measure the angles, and confirm whether the law of reflection holds true. You can use materials like string, masking tape, and protractors in the experiment. The virtual image formed by a plane mirror has the following properties. It is the same size as the object. It is upright. It is not upside down. The left and right sides of the image are flipped, known as lateral inversion. If a box or object has a mailing label on its right side, the virtual image from the mirror shows the label on its left side. The image appears to be as far away from the back of the mirror as the object is from the front of the mirror. The other type of image is a real image. A real image is formed at the point of converging light rays on the light side. The light rays actually pass through that point, and they can be projected and focused on a screen. A real image is not formed by a plane mirror, but is formed by spherical mirrors and lenses in certain situations, as we'll find out shortly.